friends. I am again here for my course Aircraft Systems. This course belongs to the module 3 of Aircraft System for 6th semester or 18 students. Today I am in lecture number 24 and topic for the today is components of pneumatic system. I am Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have covered module 1, module 2 and 3/4 of module 3. In module 1, I have discussed about the main components of the system, especially the aircraft systems. It has the 4 pillars of support. First pillar is aircraft structures or airframe. Second pillar is vehicle system. Third one is avionics system, and fourth one is mission system. I have covered aircraft structural system or airframe systems in detail in module 1. However, the vehicle system, I have covered few systems of the vehicle systems are covered in module 2, that is electrical system, oxygen system, anti-icing and de-icing system, firefighting system. These things are covered in module 2. In module 3, we have the main 2 systems. First one is hydraulic system, another one is the pneumatic system. I have covered my topic of all the topics of hydraulic system, and now I am in the second phase of module 3, that is the pneumatic system. In this also I have covered 2 lectures, and this is the third lecture on the pneumatic systems. In this following are the content of this today's topic, pneumatic system. In this I will be going for the high pressure pneumatic system, medium pressure pneumatic system and low pressure pneumatic system. And for the pneumatic system components, I will be covering air compressors, relief valve, control valves, check valves, restrictor valves, filters, desiccant and moisture separator, and pneumatic landing gear and extension system. These I will be covering in today's lecture. Previous topic, a revision. I have covered the principles of pneumatic systems, advantages of aircraft pneumatic systems, disadvantage of aircraft pneumatic systems, main component of the pneumatic systems, typical pneumatic systems. These things I have already covered. So pneumatic system, if I talk about, in olden days we used to have the low pressure pneumatic system, that is up to 3000 psi we used to have, but nowadays we have a range up to 8000 psi. This makes the system very compact, light in weight and very efficient. Some aircraft manufacturers have equipped their aircraft with a high pressure pneumatic system, that is 3000 psi in the past. The last aircraft to utilize this type of system was the Fokker F-27. Such systems operate a great deal like hydraulic systems, except they have employed air instead of the liquid. They have used the air instead of the liquid for transmitting power. Pneumatic systems are sometimes used for brakes, opening and closing of the doors, driving hydraulic pumps, alternators, starter, water injection, pumps, etc., operating emergency devices. So these are the systems which are operated by the pneumatic systems, like brakes, the wheel brakes, air brakes, your thrust reversers, all things are operated by the help of pneumatic system in case of your hydraulic system is failed. Opening and the closing of the doors are also operated by the pneumatic system. Driving hydraulic pumps, alternators, starter, water injection, etc. Operating emergency devices also use the pneumatic systems. Now I will talk about high pressure pneumatic system. For high pressure systems, air is usually stored in metal bottles at pressure ranging from 1000 to 3000 psi. Depending on the particular system, this type of air bottle has two valves, one of which is a charging valve. A ground operated compressor can be connected to this valve to aid air to the bottle. The other valve is control valve. It acts as a shut-off valve, keeping air trapped inside the bottle until the system is operated. So here I am showing the high pressure pneumatic system. So just I want to explain something about this system. If suppose this is the bottle, air bottle or the nitrogen bottle. Here we have like this. One is here. It is the charging valve. Charging valve. And here at the center, we have the control valve. So this charging valve is used to charge the bottle, and it is connected with some ground system here. And from here air will enter here and this will be closed. As and when you want that this is charged, you will disconnect this thing and you want to open this, you will open from here and this air will go from another side like this. Okay, so like this systems are used. Now high pressure pneumatic system schematic, I am showing here some system, and if you see here, starting from the normal gear operated connected here, this is a bottle here, one bottle here, and here is the pressure gauge. This is another bottle and here is also pressure gauge. Here we have the air filters. So it can be directly, it can go like this, then it will go from here. Here is the charging valve, here is a pressure switch, then here you have the abstractor, it will abstract oil and the water trap here. Then from here it goes to the dehydrator, then here it goes to the pressure relief valve, and from here again a filter, and from here it goes to the main system here. And same way another system, the left side, this is the left side and this is the right side of the pneumatic system. Both will operate from here and then it will go to the respective supply system. Here this is the main bottle here, this is another bottle, and from here this can go to air filter, this go to the normal brakes and to nose wheel steering, normal gear control. All the systems are operated and these things are used here. So I have shown a very simple diagram of a aircraft. So here we should have one compressor here, warning light if it is less pressure or more pressure, warning light should be there. Left hand nacelle, it is fitted in the engine, left side of the engine, and here is a right hand side of the nacelle of the engine, it is fitted. So this we have to see that it is working in this way. Now high pressure system for brakes. So high pressure storage cylinder is light in weight, it has few disadvantages, cannot be recharged during the flight operation. During flight, operation is limited by the small supply of bottle air. This cannot be used for the continuous operation of a system. The supply of bottled air is reserved for emergency operation of such system as the landing gear or the brakes. So this aircraft which is operating, and if the hydraulic system is failed, that time we use the high pressure system, and this is very much essential for the landing gears, because landing gears, if it is not coming out, you cannot land the aircraft. So you have to make sure that landing gears are working and the brakes are also working, because if you are landing on the runway and brakes are not working, your aircraft may override the runway and it will cross the runway. So it is very dangerous. So as an engineer, we must ensure that the aircraft high pressure pneumatic system should work properly, and it is operated by the help of the air bottle or the nitrogen bottle, which is kept charged inside the aircraft at the different location, so that as and when we require the need of hydraulics and this pneumatic system, that time pilot will operate and the system will work. So here I am showing the one brake system of the aircraft, and this by the help of pneumatic system. So here this we can see here the supply pressure. This supply pressure is given by the ground trolley, ground generator, where this high pressure air is generated. This goes to the non-return valve or the one-way valve. From here it goes to the relief valve. If the pressure of this thing is higher than the required pressure of the bottle, the pressure will be released from here, and a net amount, whatever is required for the system, only that much amount of pressure will enter inside the air bottle. As and when air bottle is charged and it caused the pressure as per the requirement, this relief valve will automatically cut this power supply and the system charging system will be cut off. From here we have from the air bottle it goes to the pressure reducing valve. This pressure reducing valve will reduce the pressure, because inside we have 3000, 4000, 5000 and up to 8000 psi we have, but system may not work in 8000. The system pressure requirement may be 1000, 1500, 2000 or 3000. So this device, that is called the pressure reducing device, this will try to make the aircraft in such a way that this system is taking the required pressure and this is reducing as per the requirement of the system. Now from here it goes to the brake control valve. From here this valve will control the brakes. This is operated by the pedal of the pilot. The left pedal or the right pedal are used, and they are pressurized both at a time, so that an equal amount of pressure is generated by the help of these pedals. Once the pedals are operated, the pressure will go from here to the actuators, rapid extension exhaust valve, and from here it goes to the brake units, right wheels, and the brake unit of the left wheel. From the left side it goes. And here we have the knob, emergency pressure, and here we have the hold, on and the off. Three positions of the switches are there. If you want to hold in the particular location, you hold it. If you want to make it off, you shift to this direction, and if you want to make on, you shift this lever to this position. Okay, so here we have three locations. So as and when you are putting to on, your aircraft brakes will be on. As and when you want to make continue on, you keep it at hold. It will remain in the same on position. But if you want to release the brake, you have to shift this lever to the off. And if you see here, this is called emergency brake control knob. So if you want that in case of emergency, this valve has to be operated and this has to work as per the requirement of the system. Another thing is the parking handle. When aircraft is parked, there is a handle. You have to push back this handle, and this will make both these pedals where these pumps are there, these cylinders will be pressurized and brake will be on. As and when you require to off, you can turn it down and your aircraft brake will be off. So this I have shown a simple aircraft brake system, and hope this will be very useful for you, and it is very nice to understand this concept. Now, pneumatic system component, I will be discussing about some major component of the pneumatic system. So pneumatic system do not utilize reservoir, hand pump, actuator, regulator or engine driven or electrically driven power pump for building normal pressure. But similarities do exist in the some components. So here we don't use accumulator, regulator, engine driven pump and all, but there is some similarity which is between hydraulic system and the pneumatic system. So first one is the air compressor. In place of there we are using pump, here we are using air compressor. On some aircraft, permanently installed air compressor have been added to recharge air bottle whenever pressure is used for operating a unit. Several types of compressors are used for this purpose. Some have 2 stages of the compression, while others have 3 depending on the maximum desired operating pressure. Relief valve. Relief valves are used in pneumatic system to prevent damage. They act as a pressure limiting units and prevent excessive pressure from bursting line and blowing out seals. So here we have air compressor. Second thing, we have the relief valve. This relief valve acts as a safety measures. As and when the pressure of the air is increased to a given value, there is a spring loaded valves. Those valves will open up and the excess amount of pressure which is acting on the system will be relieved to the atmosphere, and the pressure and the pipelines and all the equipments will be safe. So that is acting as a fuse. In electricity, we are using the circuit breakers or the fuse. So relief valves are acting as a fuse to prevent the system from a high pressure of the pneumatic system. Next is the control valve. So control valves are also necessary part of a typical pneumatic system. Figure below illustrate how a valve is used to control emergency air brake. The control valves consist of a 3-port housing, 2 puppet valve and a control lever with 2 lobes. So it is shown here that the control valve consists of a 3-port housing, 2 puppet valves and a control lever with 2 lobes. So it is shown here that here we have figure A is in off position, this one is in off position, this one, and this is in the on position. So control valve is on and control valve is off, and as I told you, there is a spring. This is the brake port. Here we have the puppet port. Here we have the drift passage. Here we have the emergency brakes. Here we have the pressure relief valve. So these are the things which are incorporated in the control valve. Now I will talk about the check valve. Check valve is also called the non-return valve, NRV. Okay, so in this the fluid pressure will go in one direction. If it is in opposite direction, valve will be closed, and from opposite direction flow will not come to the entry side. So air enters the left port of the check valve. This you can see, this is the left and this is the right. So air enters the left port of the check valve. So air enters from this side. Compresses a spring. So here is a spring and it is acting on this flap. So due to this pressure, flap will be opened. So compress a light spring, forcing the check valve open and allowing air to flow out the right port. So as and when this pressure increase, initially it will be like this. As in, due to this pressure, it will move in this position, and the flow will go from here and it will go to the required position. So this is the purpose of the check valve. But if air enters from the right side, suppose that now you try to make your air from this side. This is the right side. This is the right side. This is the left side. If you are making that, pressure should enter from this side, then what will happen? There is a spring and this will close. This valve will be closing this thing. And pressure will not come this side. Only pressure will go this side only. This is the correct and this is the not correct. So check valve will not allow the pressure to go from another side. Next is the restrictor valve. So these restrictors are also the valve. Restrictors are a type of control valves used in pneumatic systems. The figure 5, it is shown here, variable pneumatic restrictor, illustrate an orifice type restrictor with a large inlet port and a small outlet port. So here if you see, inlet is quite big here, this much size. Inlet, if you see here, the size is this much, and here the size is very much small here. So it is called a restrictor. So variable pneumatic restrictor. This position of this adjustable needle can be adjusted by the screwdriver. Just open this cover and put here one screwdriver and rotate this. If you are putting down, passage will be further reduced. If you want to make further up, passage will be more. So this needle valve will make sure that as per your requirement, the flow will be restricted or increased. So the small outlet port reduces the rate of airflow and the speed of operation of an actuating unit. So this speed of this thing will increase or decrease by these restrictors. Next component is variable restrictors. So it is a orifice type valve, and here it is an inlet from this side. It is, and this is the outlet from this side. So if you can see here that here it is very small area. This area is very small, so it will restrict the flow as per this area. It contains an adjustable needle valve which has threads around the top and a point on the lower end. Depending on the direction turned, the needle valve moves the sharp point either into or out of the small opening to decrease or increase the size of the opening. Since air entering the inlet port must pass through this opening before reaching the outlet port, this adjustment also determines the rate of airflow through the restrictor. Next is the filter. So pneumatic systems are protected against dirt by means of various types of filters. A micronic filter consists of a housing with two ports, a replicable cartridge and a relief valve. Normally, air enters the inlet, circulates around the cellulose cartridge and flows to the center of the cartridge and out the outlet port. If the cartridge becomes clogged with dirt, pressure forces the relief valve open and allows unfiltered air to flow out of the outlet port. Screen filters a handle extended through the top of the housing and can be used to clean the screen by rotating it against metal scrap. So just here you can see here that how these things are working. So from here it is entering. This entry, here you have the cellulose filter here. This you can see, this one entering here, and it is filtering and going out from here. From here it goes to this outside, and from here if any material is there unwanted will be trapped here inside, collected liquid here. This air will go to the, from here, this air will go to the outlet here, and in this type systems are working. If the pressure is high, then there is a relief valve, and this relief valve will open here and it will go to the atmosphere and your system will be safe. So center mounted stud, this is called the center mounted stud. On top of this your filter is fitted, your flow is entering from the center of this and it is going, and from here it will pass to the outlet. So this is a simple typical filter of the pneumatic system. In this way the pneumatic system is working. Next part is the desiccant or moisture separator. The another component which is called the moisture separator. The moisture separator is a pneumatic system. In a pneumatic system is always located downstream of the compressor. It means after the compressor, these moisture separators are there. Its purpose is to remove any moisture caused by the compressor. A complete moisture separator consists of a reservoir, a pressure switch, a dump valve, and a check valve. It may also include a regulator and a relief valve. The dump valve is energized energized by the pressure switch. When de-energized, it completely purges the separator, reservoir and lines up to the compressor. The check valve protects the system against pressure loss during the dumping cycle and prevents reverse flow through the separator. Next topic is emergency backup system. So we have just seen that how in typical pneumatic system works. Especially we have discussed for the brake unit and the landing gears and all. But how this emergency backup system of aircraft is done. So here we have seen that many aircraft used a high pressure pneumatic backup source of power to extend the landing gear or actuate the brakes. If the main hydraulic system braking system fails, the nitrogen is not directly used to actuate the landing gear, actuators or brake units, but instead it applies the pressure nitrogen to move the hydraulic fluid to the actuator. This process is called the hydraulics. Okay, so hydraulics, it is a new terms, hydraulics. This hydraulics means pneumatic system pressure is used to drive hydraulic system. Okay, so this is called the hydraulics. It consists of, so in this hydraulics, what are the components? So in this, first is the nitrogen bottle near the wheel to apply wheel brakes, gear emergency extension cable and handle, and the dump valve. So these are the very important and few very much essential components of this thing is nitrogen bottle, gear emergency extension cable and handle, and dump valve. Next important part is the chemical dryer. It is very much essential to dry the air. Otherwise the moisture, if the moisture is there, it is very dangerous. It will cause the rust, it will cause the corrosion and the system, and it will be also having lot of density problems. So pressure variation will also take place and your efficiency of the system will be reduced. So we need some device which should be able to prevent the moisture from the entering in the system. So one of the method is the chemical method, and we use the chemical dryer as shown in this diagram. So chemical dryers are incorporated at various locations in a pneumatic system. Their purpose is to absorb any moisture that may collect in the lines and other part of the system. Each dryer contains a cartridge that should be blue in color. If otherwise noted, the cartridge is to be considered contaminated with moisture and should be replaced. So if there is a cartridge, so here wet air is entering from here, it is going like this from here, drain solution, collection chamber here, collecting screen here, this here is a desiccant here, this will absorb water, and if extra water, it will be drained out from here, and it will go, a dry air will go from outlet here. So this is very much important, and chemical dryers are used. Here chemical is used to, you might have seen in the packages, they put some chemicals inside the boxes, packing boxes, so that any moisture which is entering, it will be absorbed by this. So all this electronic machine, TV, fridge, AC and all, if you see their packing, they are putting some baggage, some small packets, and these packets are absorbing the moisture. Same way here, same type of packets are fixed in this chamber, and these chambers are used to operate the, and used to absorb and make it dry. Air should become dry. Now some complications started, and pneumatic emergency landing gear extension system. Just I am going to discuss about this. Pneumatic emergency landing gear extension system. Here if you see, this purple color is left system, orange is right system, green is PTU system, auxiliary system. So this all colors are indicated here, and if you see here, here we have the emergency log gears. Here this is the right system, and here is the left system. Here is auxiliary pump, auxiliary shut-off valve, auxiliary pump. Here we have the pedal inputs. Here it will go petrol emergency brake, parking brake valve, wheel brake valve, nose wheel is operated by this way. Here also if you see, landing gear dump valve, landing gear forces, landing gear. So these landing gears are operated by this blue system. This you can see here. This is R, and this is the right, and this is the left. Left engine pumps here, here the right engine pumps. They are operated by the engine. These engines fitted, these pumps are fitted on top of the cowling of the engine. So if we have this one engine here, on top of this small, these pumps are fitted. Okay, so like this, we can make the system, and we can understand this landing gear methods and brake, parking brake, all the systems, how these things are operated, that we can understand. Now, till now I have talked about the high pressure. High pressure means it is 2000 to 8000 psi. Once I talk about the medium pressure pneumatic system, the pressure is ranging from 50 to 150 psi. PSI means pound per square inch. A medium pressure pneumatic system is ranging from 50 to 150 psi. Usually does not include an air bottle. Instead, it generally draws air from the compressor section of a turbine engine. This process is often called the bleed air. Okay, so this medium pressure is called the bleed air, and is used to provide pneumatic power to engine start, engine de-icing, wing de-icing, and in some cases it provides hydraulic power to aircraft systems. So hydraulic power, if the hydraulic system is equipped with an air-driven hydraulic pump. Engine bleed is also used to pressurize the reservoir of the hydraulic system. So bleed air is also used for pressurizing the hydraulic system. Okay, so very much essential that we have to understand this medium pressure, and they are used for the, we are taking some part of the, this is the, just I am drawing here, air is entering, this is the engine, we have here so many compressor stages. So this is the LP and HP. So as per the pressure requirement, we may take from the LP or we may take from the HP. This is called the bleed air. Bleed air is taken from the engine, and this is used for the engine startup, for the engine de-icing. If ice is formed, we can de-ice it. Wing de-icing, and some cases it provides hydraulic power to aircraft system also. Also it is used for pressurizing the hydraulic system. Okay, so low pressure pneumatic system. Further, if you want the very low pressure, that time a vane type pump used for LP pressure system. These pumps are driven by electric motor or by the aircraft engines. This figure shows one of these pumps, which consists of a housing with two ports, a drive shaft and two vanes. The drive shaft and the vanes contain slots to the vane, can slide back and forth through the drive shaft. The shaft is eccentrically mounted in the housing, causing the vanes to form four different sizes of the chamber A, B, C and D in the position shown. B is the largest chamber and is connected to the supply port. Outside air can enter chamber B of the pump. When the pump begins to operate, the drive shaft rotates and changes position of the vane and sizes of the chamber. Vane number 1 then moves to the right, separating chamber B from the supply port. Chamber B now contains a trapped air. So just you can see here that here is supply port, and this vane 1, vane 2, chamber B, this you can see it is more area. As you move from this side to this side to this side, area is reducing and pressure is increasing. So this is the function of the vane type of pumps, and they are directly attached with a electrical motor. In this way we can use this type of pressure system for a low pressure devices. Pressure reducing shut-off valve. It is shown here, the Harrier. You know, the Harrier is very good vertical takeoff aircraft, which was used in our Indian Navy for the INS Vikrant, INS Virat, long time. From last 8 to 10 years, these Harriers are replaced by the Russian MiG-29S. These MiG-29S are operating from the INS Vikramadit. INS Vikramadit was obtained from the Russia. So as Harrier word came, and this pressure reducing shut-off valve schematic is shown here, and you can see here that we have here inlet, high pressure bleed air. Here it goes to the this part. Here temperature sensing is there. Here the reverse flow sensing is there. This you can see the position switch. Here we have the solenoid valve. Here we have the actuator valve. Here we have the pneumatic pressure. Here on off command. So if you give the on off command, this actuator valve will open, and accordingly it will, valve operation will move left or right, and the passage will open as per the requirement. So if you operate, it will close like this, or if you operate like this, it will open. So it is just closing and opening like your water tap. If you put like this, it is open. If you make like this, it is closed. So this is the shut-off valve, pressure reducing shut-off valve. So it will reduce or increase the pressure. Also, it will either stop, it will make on or off of the system pressure as and when it is required. So I have completed my today's lecture, and for the next topic, for the next class, I am going to discuss about these topics: introduction to pneumatic system in aircraft, different function of bleed air, uses of bleed air, characteristics of a modern turbofan engine, relationship of bleed air with major aircraft system, simplified bleed air systems and associated aircraft systems, engine bleed air system, engine bleed air systems, pressure reducing shut-off valve, bleed air system indication. These I am going to, especially if you see here, most of the things are from the bleed air, and you know that bleed air is taken from the high pressure or the low pressure compression side of the engine. So in the compressor, we will take some tapping. From there, we will take some air, and this air is used for this type of purpose. So this is the objective of this system. These are the references which normally I take in every class. I use the Moir and the Seabridge aircraft systems, mechanical, electrical and avionics system. This is from the Professional Engineering Publishing Limited, London. And another book is again from Moir and the Seabridge, Design and Development of Aircraft Systems and Introduction, AIA Education Series, AIA 2004. So these are the two books. However, I am also referring some net materials, and I am putting in my lectures. Okay, so thank you very much. I am just stopping my lecture here. If any questions, you are welcome to ask me. This is my email ID. Please like it and subscribe my channel. Thank you very much for joining. Meet soon. Thanks.
Like, share and subscribe. Hit the bell icon for more updates.